In this part of the Vehicle AI tutorial series, we will allow our AI vehicle to speed up in straights and slow down in turns. So without further ado, let's get into the video. Okay, so before we get into the throttle code, I kind of want to explain how the throttle code is going to work. The last time we actually took an image of the car going around a turn, and I explained how the turning code was going to work. Now this time I'm going to do something similar for the throttle code, so let me just go ahead and open up this image. Now, last time when we did the turning code, what we did is we took the angle of the car, so the angle it was facing, and then we took a point further ahead from the car along the spline, and then we determined the angle between these, so the difference in angle between these two angles. Now, the reason why we took a point a bit further ahead from the car is because in real life you look ahead of your windshield to determine how you should turn. And this was similar to that. If we put it too close, the AI would just turn rapidly for no reason. So we had to add a bit of distance to smooth that out. Now, the throttle code is actually very similar to this, except instead of being sampled so close, or the point we're using being so close, we actually take a very far along point. So let's say about here. Now, the reason for this is because when you want to throttle, or you want to find out the top speed you should be going, you want to know as much of the track as possible. And so if we were to sample a smaller point, let's say here for example, the problem is that the car would think, oh wow, this is just a really small turn. I can go top speed and there's going to be no problems. And then it just crashes over there. And that's bad. So what we do is we sample a further along point so that the car knows, oh, this is a turn that's going to be a bit harder, so maybe I should slow down. And that's how that's going to work. So all we do is, once we have our further sampled point, we just go ahead and determine the angle between the front of our car and this point over here. And then once we have the angle, this isn't actually going to control the throttle. No, this is going to determine the top speed of the car. So the bigger this angle is, that means, oh, this turn is wider, or this turn is sharper, so I should slow down. The smaller this angle is, the more we know, oh, it's a straight, I can actually go top speed over here. And that's how the throttle code's going to work. We're going to determine the top speed the car should be going, take the top speed from our car, the speed it's currently going right now, and then we just make sure we throttle and brake as needed to reach our speed milestone, or the speed we need to reach. Now with that out of the way, we can go ahead and go code all this throttle code. Now the benefits of this system is that it's very similar to the turning code, so it's going to be really easy to change our turning code to work with throttle. Now with that out of the way, let's go ahead and actually code. We're going to Alt-Tab into Unreal Engine. Of course, you're just in Unreal Engine. And what we're going to do is we're going to open up our content browser. Then if you're in your concept folder, you want to go to your AI folder, and you want to open up the BP AI path. Now, you're going to be probably in the event graph, so all we want to do is we want to open up the get closest location to AI path interface over here. And last time we actually made this bit of code here. So we added the additional distance we did over here with this graphic. Now, the problem is that with the throttle code having to require a bit more distance than the turning code, we're going to have to make this an input to our get closest location to AI path to make sure we can easily reuse this code without having to make separate versions for each car and that. So we just want to make this code as versatile as possible. To do that, we're going to have to change our get closest location to AI path in our Blueprint interface. So let's go ahead and open up our content browser and go to the BPI underscore is AI path. We're going to open it up. And here we have the get closest location to AI path. We're going to double click to open that up. And then once we click on this function here in the top right on the get closest location to AI path, we're going to go to inputs, add a new input. We're going to change the type from Boolean to float because that is how the distance is stored. We're going to just change this new param to additional distance. Should be a good name. And the reason for calling it additional distance is because we're adding more distance to the AI path point we're sampling. So let's go ahead and compile and save. We're going to close the BP underscore is AI path. And now that we have this additional distance, all we can do is we can right click here in the open. We can type in additional distance and just drag in this value, and it will take this input over here and plug it into here. This is just a neater way to do that. And now we have our additional distance code. Let's go ahead and compile and save, close that down. We shouldn't need anything with that for now. And let's go to our AI code itself. To do that, we're going to open up a content browser. I'm going to open up the AIC vehicle AI. And now you can see we're in the calculate steering function. So if you're not in the calculate steering function, just go ahead and double click to open it up. But now that we're here, we can see, oh, our additional distance input is over here and it's set to 0 by default. For now, let's go ahead and set this to 500 like it was in our preview. We're going to change this value out a bit later to smooth out the turning and throttling, but for now, let's just get the throttle code up and running. So what we're going to do is we're going to go to our event graph, close the calculate steering function. And what I'm going to do is I'm going to go to the bottom left under functions, right click the calculate steering, and go ahead and duplicate it. The reason for this is that the calculate steering function should be very similar to the calculate throttle function. So I'm just going to copy and paste it and make our lives way easier. Now we're just going to go ahead and rename this calculate steering to calculate, what should it be? Throttle. Calculate throttle / brake. I recommend using a lowercase b because if you use a uppercase b, it might mess around with formatting and stuff, and it might be a bit harder to read. But now we have our calculate throttle and brake code. To get closest location to AI path, what we're going to do is we're just going to make this value about 3 times the one we use for the turning code. So in this case, it would be 1500. And now this should be good. This map range clamp node, on the other hand, we're going to have to change this. So, okay, so the first thing we have to understand is that this angle over here is useless, right? With the throttle code, it doesn't matter if the turn is left or right. We only want to know the angle, not the angle. Yeah, we want to know the angle of the turn. We don't want to know if it's going left or right. We want to know how big the turn is. So this minus ranges are pretty much useless. So what we can do is we can drag off this return value z and type in absolute float. We can select that. What this does is this removes the minus of a float value. So if the turn was a minus, which means it was going left, I believe, then what it would do is it would just make it a positive one. And so we only get the angle of the turn. So we're going to connect that to the ABS, and we're going to connect the ABS, the absolute, into the value, I mean. And the in range we're going to set to 0. And then the in range B, we're going to set the value to 40. So any angle between 0 and 40 is going to affect the outranges. Now the outranges, the bottom one is the fastest you want your car to go, and the outrange B is the slowest you want your car to go. So for the fastest, I find that this car can go 150 quite easily and keep high speed with that. But the lowest I find it able to do turns is 50. Now these values you're going to want to customize based on your needs. You probably want to make these variables on the car themselves, so that when you have more different cars, you can easily just customize these settings on the car, and the AI will be able to use different cars' settings. So this is a value you probably want to save directly on the car, but I'm going to save time by not making it a variable on the car. But these are the values I find works pretty well. Now the return node, this shouldn't send out a steering input, so we're just going to go click on this return node. We're going to change the output from steering input to top speed. So actually, yeah, no. This, I think let's remove the output over here. So what we want to do is we want to calculate the top speed with this. So this is the top speed. So what we want to do is we want to get the car's current speed, and with that we want to determine, oh, is the car going too fast or too slow? So this is the speed we need our car to go. So this, I think I should go ahead and go to the bottom left under functions, click on calculate throttle brake. I think it should be more fitting if we rename this to calculate top speed so that we know, oh yeah, this is the top speed. So we're going to right click, rename, and calculate rename this to calculate top speed should be a fitting name. And then we're going to go to our return node, add an output, make it a type float, and we're going to call this top speed. So this is the top speed we should be going. This is the speed we're aiming to go. We can plug in the return value. Now this, we are going to rename this comment block over here because it says convert angle into steering input. No, we're going to just go ahead, double click on that, and change it convert angle into top speed. Okay, we're going to widen this block over here, move the return node, and try to get the absolute node in here. Something like this is perfect, and this is sorted. I'm going to compile and save. Now we're going to go back onto our event graph, and then we're going to remove our set throttle code here. So, did Unreal Engine crash just now? Wait, what? Oh no, it just it just slowed down. I was scared there for a second. Okay, and I fixed Unreal Engine. I was kind of scared it was gonna crash there, but it is totally fine. So what we're going to do is we're going to drag in our calculate top speed over here, connect that to this set steering. So the set steering connects to the calculate top speed. And this is the top speed we should be going. So what we need to do is now we need to take this top speed and calculate the throttle / brake input. So to do that, we're going to go ahead, go to the bottom left under functions, create a new function, and this one's going to be called calculate. This one's going to be the calculate throttle / brake. So this code will be the code that actually determines how much throttle or brake we should be using. Okay, so what we're going to do is we're going to add input, and this input is going to be of type float, and this is going to be top speed. Let me just capitalize that correctly. Okay, so this is the top speed we should be going. Now what we want to do is we want to get the current speed of the car and compare that to make sure, okay, this car is going faster than top speed, we should make it brake. If it's going slower than top speed, we should speed it up. Now the problem is that we have no way of getting the current speed of the car. So we are going to change our blueprint interface, which gets information from the car, to add a function that will get the current top speed of the car, or the current, speed of the car. So to do that, we're going to open up our content browser. We're going to go to BPI is vehicle and double click to open it up. We're going to add a new function over here. We're going to call this get current speed. So this will get the current speed. We're going to add an output. It's going to be type float, and then we're going to rename this to current speed. And yeah, that should be good enough. We can compile and save. Then what we're going to do is we're going to open up our content browser, go to our content folder, vehicle template, blueprint, and open this vehicle advanced pawn. And then what we want to do is we're going to go on the bottom left, under interfaces, we're going to open it up, and then we're going to open the the get current speed. We want to double click and open it up. And this is where we're going to output our current speed. So how do we actually get the current speed? So to do that, we right click and get forward speed. Now there's going to be two options, get forward speed and get forward speed miles per hour. Now what I prefer to do is use get forward speed, so like this, and then what I like to do is I like to drag off this return value, do a multiply, and then I multiply this value with 0.036. Now what this does is converts this get forward speed into kilometers, which is just easier for me to work with. We can have a fight about what metric system you like to use, but I just like kilometers per hour, so I'm going to be using that. You can also just use the miles per hour one if that suits you better. But anyway, with that out of the way, let's go ahead and connect this to the current speed. Let's just move this return node. We're going to move this code over here. Just move this in here. Going to select all three of these nodes, press C to comment, and we're going to call this get current vehicle speed in kilos. I think I'm just going to use kilos because I feel like it today. But anyway, this is our top speed code, or this is the speed of our current car. We're going to compile and save, close down our vehicle because we're not going to need it. And now all we have to do is we have to compare the top speed with the current speed of the vehicle. So we're going to go ahead and in the bottom left under variables, we're going to drag in our controlled vehicle. Then we're going to get our controlled vehicle. We're going to drag off this and use get current speed message. And now we're going to just go ahead and move that over here, plug it into the calculate throttle and brake. And this is our current speed. So this is the speed we are going. So what we do is if the current speed is smaller than the top speed we should be going, we're going to throttle. If the current speed is bigger, that means we need to brake to actually get this, to actually make it slower to fit the top speed. So to do that, we're going to drag off the current speed, and we're going to do a bigger or a greater or equal. Actually, yeah, let's do a greater and equal. And then what we're going to do is we're going to find out if the current speed is higher than the top speed we should be going. So because this is an input to the function, what we can do is we can right click and type in top speed, and we can use this variable get top speed, and that is this variable over here. We can connect that. So if this top speed, or if the current speed is bigger than top speed, we should be braking right now. So let's go ahead and code that. We're going to drag off this execution node. We're going to type in branch for a branch node. You can actually hold B on your keyboard and left click to shortcut that. But anyway, we're going to drag this greater or equal into the condition. So if this is true, if the current speed is higher than the top speed, we should be braking. Now, if I'm correct, if we open up the content browser and we go back to our AI folder and open the BPI is vehicle, we have the set throttle, set brake, and set steering. Okay, now we're totally fine. Okay, so now how is this going to work? Now how this is going to work is we're going to output a throttle and a brake value. So what we're going to do is we're going to click on this calculate throttle brake. We're going to go to the bottom right and add two outputs. One is going to be throttle. Why can't I spell now? I mean, I spelled this so many times. Anyway, this one's going to be throttle. The second one's going to be, I didn't even type. This is going to be brake. Now, both of these needs to be floats, so just make sure they both are floats. And then all we do is we drag this return node over here. So if it is true, we are currently faster than the speed we should be going, we're going to connect the true value to this return node. What we're going to do is we're going to make the brake 1 and the throttle 0. But if it is false, we're going to copy and paste this return node, connect the false to it, and what we're going to do is we're going to set the throttle to 1 and the brake to 0. So we then throttle because we're going slower, and then we don't brake. So we just switch out these inputs as needed. So we're going to compile and save, go back to our event graph, and now we have the calculate top speed. We're going to go to the bottom left and drag in the calculate throttle and brake value, plug that into the execution pin, plug in the top speed, and now the throttle and the throttle and brake code. What we're going to do is we're going to set the inputs of the car with these values. So that how are we going to do this? Oh yeah, we're going to go to the bottom left, drag in the controlled vehicle, drag off that, and do a set throttle message. We're going to connect that, connect the throttle to it, and then finally we're going to drag off this controlled vehicle again. We're going to use set brake message. We're going to connect the execution pin, connect the brake value to that. We're just going to use pins to move it around to make it look a bit cleaner. So yeah, something like this should be enough. Maybe if yeah. So something like this should be good enough. So this should work. So let's go ahead and compile and save to see how it works. This starts simulating the game. I'm gonna use selected viewports. So let's see what the car does. You can see it is not really doing a good job. It's overshooting it quite a bit. So it also is wiggling a lot. So this is actually to be expected. The reason for it is because those values we set, they aren't actually good. Now I'm going to explain why. Now the reason why they're not good is if I go to the set steering, actually not the set steering, the calculate steering, right? This additional distance would have worked if our car was going 50 kilometers per hour. But the problem is that our car isn't always going to go 50 kilometers per hour. And so the moment our car goes way too quickly, it needs to look ahead more. Else it's going to be stuck in the past. It's not going to get enough information to turn correctly. So this additional distance, we actually need to get the speed of the car to change this value and improve this value. So what we're going to do is, at this calculate steering, we're going to drag this to the left a bit. Then we're going to go ahead and go to the bottom left on the variables. We're going to drag in controlled vehicle and use get controlled vehicle. We're going to go ahead and drag off this and do get current speed. Yes, get current speed. And then we're going to just plug that into the execution pin. And then this current speed, we're going to use this to determine how much additional distance we should be adding. So how are we going to do this? Well, we're going to drag off the current speed. We're going to use a map range clamp. So, yep. And the in range should be 50 because that is the slowest speed we should be going. And then the in range B should be the fastest speed we're going, which is 150. And then the out range, I find the following values work the best. 1000 to look ahead, and 3000 if he is going at 150 kilometers per hour. So if you don't know what's going on, this converts speed into distance. So the more speed we have, it converts it into more distance to look ahead. And so we're going to go ahead and plug in this return value. I'm just going to widen this comment block. Connect this execution pin up, just widen this comment block again, move the controlled vehicle in, and yeah, this should be good enough for now. And let's go ahead and compile and save. And just like we had to do this for the turning, we also need to do this for the throttle code so that we know, okay, if we're going quicker, we need to see more of the track. So let's go to our calculate top speed. We're going to move our calculate top speed to the left a bit. Then we're going to go to the bottom left, drag in our controlled vehicle, use get, drag off of that, and do the current, and use get current speed, right? We're going to connect this execution pin up, and just like last time, we're going to drag off from this current speed. We're going to use a map range clamped. We're going to set the A value to 50 and 150 because those are the speeds we calculated over here. And then the outrange A, I find that this value should be 3 times the turning code with the specific car. So what I do is I set the outrange A to 3000 and then 9000, and this provides the best settings for these cars. What I would prefer you do is you, of course, just like we used the get current speed, you probably want to make these values variables for your car so that if your car has different handling, each car will have different handling. This means that this will actually get this value from the car, and so all the cars will be able to handle correctly if you actually assign good handling information to them. But with that out of the way, let's drag this return value into the additional distance, widen this comment block again, maybe move this a bit to the left, and then finally we're going to drag this get current speed into the get front of car. And now we change the additional distance based on the speed of our car. So let's compile and save. Let's see how this works. Press play. You can see, okay, I'm just going to press F8. That's going to make it easier. You can see he is going slower around the turns, but he's speeding up at the straights. Then he's starting to brake again so that he handles the turns better. Then he throttles and brakes. And he's doing a pretty good job, actually. He might be taking the turns a bit too close for my liking, but this should be easy to fix with just a few number changes. But you can see, okay, it's doing the turn. It's braking into the turn, and then it's going to brake in here because this is a wide turn. Then it's going to use hyperspeed in the straight, do this turn over here, and then hyperspeed in the straight. Now, what I like about this is that if I play this again and we go spectate this car again, what I like is it goes slow into the corner and then it speeds up near the end, so that it creates this nice gradual speed up, which is really good looking. And yeah, of course there is no brake light so that you can actually see how its braking behaviors work. But in the next episode, I'll explain how to give the AI a better brake light. So I'll explain how to make sure this AI actually uses a brake light. Yeah, this is pretty good for now. What I would suggest you do is change around these values, find out values that works well for you. Here in the top speed code, here where we do the convert angle into top speed, you can maybe try raising the top speed that the car should be going. Maybe if you think the car can go faster through bigger turns, maybe you can up this value. Maybe you feel, maybe you think the car needs to look ahead a bit further. You can do that, and maybe you want to add additional distance to the steering, so that if this car is steering too wide, you can just adjust these values to make it better. So just go ahead, experiment, try to find out the best settings for the car. If you have some really good settings you might want to share with us, just post them down in the comments. Maybe that could help someone like me, for example, but maybe some other people watching the video. Yeah, but that's it for this tutorial, guys. Thanks for watching. If you liked the content, please subscribe. Hit like if you liked the video, hit dislike if you didn't, and see you guys in the next one. Good night, everybody.